Hello viewers, in today's class we are going to discuss one very important problem from differentiation in which trigonometric substitution would be used, right? So here we have to find the derivative of y is equal to tan inverse square root of a minus x divided by a plus x with respect to x, where this condition is given, that is x lies between minus a and a, right? So here we'll differentiate y with respect to x, making use of some important transformations from trigonometry, right? And moreover here this condition is very important, right? And we'll make use of this condition in some later stages, right? So let us start. So here we'll take x is equal to a cosine theta, right? So here we'll make this substitution, because see, when we take x is equal to a cos theta, then this expression can be simplified by making use of other identities, right? So let us first simplify this expression. So we have y is equal to tan inverse square root of a minus a cos theta divided by a plus a cos theta, right? And now we can write tan inverse, and here we have square root of, we can take a common in numerator and denominator, so we can have 1 minus cos theta, and here we have a times 1 plus cos theta, right? So now this a and this a get cancelled. We are left with tan inverse square root of, we have 1 minus cos theta divided by 1 plus cos theta, right? So now to move further, what we will do, we'll make use of two important results from half angles, right? So we know that 1 minus cosine theta is equal to 2 times sine square theta over 2, right? And the other identity is 1 plus cos theta is equal to 2 times cosine square theta over 2, right? So when we have here the negative sign, then we have the term sine, and when we have the positive sign here, we have the term cosine, right? So now y can be written as tan inverse, and we have a square root of 2 sine square theta over 2 divided by 2 times cos square theta over 2, right? Now this 2 and this 2 get cancelled, and we are left with tan inverse square root of sine square theta over 2 divided by cos square theta by 2 is tan square theta over 2, right? Okay, now here see, we have the square term, and here we have the square root. Now we cannot directly cancel this square term by this square root, right? So what we will do here, we'll write this square root of tan square theta by 2 like this. We can write tan inverse, and we'll write the mod of tan square. We can write it as tan theta over 2, right? So here we have used the definition of mod function, right? See, mod of x is equal to square root of x square, right? So here square root of x square means tan square theta over 2, which is equal to mod of tan theta over 2, right? Okay, so now here comes the role of this inequality, right? So we have, see, we have minus a less than x less than a, and see, here we have substituted x is equal to a cos theta, right? So now we can substitute here a cos theta. So we have minus a, and here we have a cos theta, and here we have a, right? Now if we eliminate a throughout this inequality, we'll get minus 1, and here we have cos theta, and here we have 1, right? So we can divide throughout by a, and obviously a is not equal to 0 here, right? Okay, So now we have cos theta lying between -1 and 1, right? So this implies that theta must belongs to the interval 0 comma pi, right? So this is simple trigonometry. So theta belongs to 0 comma pi interval, right? So here we have the angle theta over 2, right? And here we have theta. So theta over 2 belongs to 0 comma pi by 2, right? Because see, theta belonging to 0 comma pi can be written as theta belongs to 0 to pi, and if we divide throughout by 2, we get 0, and here we have theta by 2, and here we have pi by 2, right? So theta belonging to 0 comma pi implies that theta by 2 belonging to 0 comma pi by 2, right? And when theta over 2 belongs to 0 comma pi by 2, it implies that this is the first quadrant, right? So we are in the first quadrant, and in the first quadrant all trigonometric functions have the positive sign, right? So tan theta over 2 must be positive, right? So tan theta by 2 is positive. So mod of tan theta by 2 can be written as positive tan theta by 2, right? So here we can now write tan inverse, and here we have tan theta over 2, right? So now from inverse trigonometric functions, this tan and tan inverse get cancelled, and we are left with theta over 2, right? And moreover here, we know that the principal branch of tan inverse x is from minus pi by 2 to pi by 2, right? Okay, so now we have y is equal to theta over 2, and from here x is equal to a cosine theta. So cos theta can be written as x over a, and theta can be written as cos inverse x over a, right? So here we can now write half cos inverse x over a, right? So finally we have got the function y is equal to half of cosine inverse x over a, right? So now we can differentiate both sides with respect to x. So dy over dx is equal to half d by dx of cos inverse x over a, right? And we know that the derivative of cos inverse x is minus 1 over square root of 1 minus x square, right? So here we have half, and the derivative of cos inverse x over a is minus 1, and we have 1 minus x over a square, and by chain rule here we have the derivative of x over a, right? Now we can simplify it. So we have half, and we can now write this term as minus a over square root of a square minus x square, and here we have the derivative of x as 1, so we have simply 1 over a. This a and this a get cancelled, and we are left with minus 1 over 2 times square root of a square minus x square, right? So this is the required derivative of y with respect to x.